Hi, so this is part 3 of the LCD, continuing where I left off a couple of minutes ago. Right, just watch the screen scrolling through the random text. Excuse me. Right, do you remember we wired port B5 up to a switch? If you ground the switch, it was going to go to a second loop, which will come up in a second. I'll explain more about this scrolling text and loops and getting stuck in a loop later. Well, so I've grounded pin 2 because I don't have a switch, just ground it with a jumper wire. Right, it's finished doing the scroll text loop. It looked at the program, seen I've got port B5 pin 11 grounded, and the program's jumped to this second loop. As you saw earlier, it just shows a subroutine, second line of text. But now, if I disconnect, hopefully you can see it, if I disconnect this switch, the LCD should continue what it was doing. But it isn't, it's stuck in that loop. It's not going to go anywhere else, it's not being told to look at the switch anymore. Just went to the second text and stopped there. So now, ordinarily you'd have to unplug the chip from the breadboard, plug it in this 0 insertion 4 socket, which is I've described in the first video, program it and put it back, etc, etc. Every time you try a line of text, got to keep on swapping it over. So that's why I recommend this in-circuit serial programming. 4 to 5 wires. You remember master clear, program data, program clock. I've grounded my programmer to the breadboard just so it's got a ground, but don't need a supply because I'm running a battery pack on the breadboard. So 4 lines gives you your in-circuit serial programming, and from there I can just keep on trying different programs, hitting F9 was a shortcut to program, and we're there. So if I focus back on the screen, so it's stuck in the second loop. Let me get all the screen in shot. Stuck in the second loop. Hopefully you can see this. Do you remember we put go to, and I think, excuse me, just before the end of the other video, as go to, yeah, if switch 1, which is the switch we allocated to port B pin, port B5 pin 11. If switch 1 is ground, it goes to the second loop. So I grounded the pin, jumped to the second loop. It's the second loop in this program, this simple program, Microcode Studio Pic Basic Pro, loop 2, so it clears the screen, LCD out, shows subroutine, LCD out, $FE, $C0, second line of text. So this is, I was demonstrating really how easy it is to get some text on an LCD using Microcode Studio and Pic Basic Pro. I think, as I've described in the other videos, there's a Micro C, which you can get boards and all that sort of stuff. Micro C uses C language, but I found to be more expensive than Pic Basic Pro, and like a Pic Kit 2 programmer. Right, so why is it stuck here? Well, it's come to here and the program ends, doesn't go anywhere else. So what it's best to do, so although we've got go to, the programs, all of this is in the program, it's going to get to here and go to the second loop. And the rest of the programs will be stored in the hardware stack. If you get up the data sheet for the 16F627 or the 16F877, actually no, the stacks are back at the top. Just a quick guide into the hardware stacks. I'll reduce this down a bit. Quickly find the stacks, see if I find the information quickly. Right, 8-level deep hardware stack. When a program is running, or the microcontroller is running a program, when it's called, when it's told to do something else, it saves what it was doing in one of these stacks. So they're only 8 deep. So you start to telling the microcontroller to do sort of 9 things, one of these bits is going to get lost. So the program goes in on an endless loop and gets stuck. You start losing programs or software or whatever like that. So Using the go-to, we're going to be using one of these. So I recommend, rather than using the go-to, we'll go back to this go-to loop 2. We'll take that out, use the go sub as I mentioned in the last video. But I'd already done that, hadn't I? Pressed F9, which programs it. Takes a few seconds, you'll hear the bing in the background. Right, so that's programmed via the in-circuit serial programming. Program the LCD. I've reconnected the wire so the switch is on. Jump to the second routine, disconnect the switch. So using a subroutine, jumps to the subroutine, but it's still stuck there. Why is it stuck? Well, I've made an error. Go back to the screen. Now, without having to swap any of the processor, scroll the way down, goes second loop, does the subroutine. But I've actually deleted here by putting this mark here. I've deleted or grinned out this return, so put a return here, press F9 again and correct the program. So no messing about with the chip or anything, just a quick F9, alter the program, and it starts from the beginning. In a minute it's going to see the switch is grounded. Actually no, it's not, because I've disconnected it. Right, let it finish this routine. So obviously it's demonstrating LCDs with Pic Microcontrollers. You saw the wiring in part LCD part 1. This is just showing some other software programs. Right, so now the switch is grounded, jump to the subroutine. So if I haven't touched anything, it's finished the subroutine, and with that return it's resumed the rest of the program, because I put return at the end. So now it's just gonna, it'll do scroll through loop 1. If the switch is down, it's going to go to loop 2, show that second subroutine, and then it's going to go back to where it left off. That's just using the GZUB, which is go subroutine, and obviously not forgetting to put return. Right, so I won't touch anything. Do you see? So we're not stuck in a loop anymore. If I disconnect that wire, then that second part of the that subroutine is not going to be included anymore, because the switch is now not grounded. Actually, talking of grounding the switch, unless you've enabled pull-ups in the software, which I haven't, you have to pull up, so literally tie the spare ports, tie them to live. So I've got like a 10k resistor. I think you can use like 4k 7, 10k. So I've got 10k resistor connected to port B pin 5, sorry, port B5 pin 11, just tying it high to 5 volts. Well, I don't think I've got time for anything else, so thank you very much.